Welcome back to the healing bench, ladies and germs. Today I'm going to go a little bit over on transistors, MOSFETs, because we're going to put this fancy dancy little doodad in, you know what I'm saying? Know what I'm saying? Look at that canted cage, CNC'd aluminum, very, very nice quality here.
Warning. The following program contains a Canadian redneck who doesn't quite know what he's doing, coarse language, and mature subject matter. Viewer discretion is advised.
Hey, on the operating table, we have the Vulcan. For the flywheels, we went with the orange. Serrated, and I opted out for out of darts Krakens. See? You see that? Oh. Yeah. So, one nice thing about MOSFETs is that if you don't want to, you don't have to rewire anything here. For right now, I'm just going to leave all the locks in because I don't mind. So, pulled this guy out the battery door on the other side. Pull this guy out. We're just going to completely remove this. And we'll save this for a later project. So, take that out. We got these two nice wires. Very good, very good. So these are going to be going to, this is going to be our gate, essentially, for transistor and ground. MOSFET, I should say. So these are your super skookum. Let's see if you can get a good view of that part number there. See it? 785 1275 November Delta. When you're working with this stuff, you should have an anti-static wrist strap. They're real cheap and they work. I'm going to put this to my left arm because my left arm is usually more out of the way. And I'm just going to attach this to, don't attach it to wood, because that ain't going to work. And honestly, the best place to hook up is somewhere that's grounded. So, I'm just going to hook on to my belt sander, because that is a grounded piece of equipment. So if you're running some other circuits, like what we will be doing in my Stampede, we're going to want some prototyping boards. So we got this kind here. It's for the really, really small pinouts, like the SMD kind, surface mount device. Then we got the, which one's this? This is a SOP16. That first one was SSOP28, if you can read that. It all depends on the desired outcome. Realistically, for a Nerf gun with a MOSFET, you can get away with just tucking the MOSFET in somewhere. And for us, okay, we'll have to get in that a little bit. We'll do that behind the scenes because you guys probably already know what's what. Okay, so if we're gonna search up this part number. Let's do that real quick. Even go back. So you type in the part number, you go into DigiKey, come down to the data sheet, you click the data sheet. We've already got that. Open the file. Okay, so we're in here. So it's got your maximum voltage. So depending on which one we've got, which is, we've got the 240. This is the AOT 240L. You can see that on the manufacturer part number. So that's this one. So you got your drain source, your gate source. All kinds of information. A lot of it is irrelevant. You can graph the characteristics. But here we go. Well, that's neato torpedo. Any words? So basically what we're doing, so we've established which is the gate, which is the drain, and which is the source. So these can handle up to 40 volts between the drain and the source. So if we're going to take one of these, which we will, okay, so pay no attention to these guys here. It's for an ammo counter build. So we've got our N-channel MOSFET in question here. So what we do is we take our positive, and that essentially goes, our positive is going to go to our motor. Then from the negative side of that motor, we are going to go to the middle leg of said transistor. After we do that, we are then going to take a diode. Notice the positioning. The stripe is attached to the middle leg, and the other side is attached to the right leg. So the line on the diode is attached to the drain. Because if you remember, here it is on the left. Gate, drain, and source from left to right. So, need a little diode that can handle the load. And then from the other side of that diode, we go to our negative. Now over on the gate, this is essentially going to be our switch. At the other end of this, we'll have a switch. But to simulate that, I am just going to touch it to the positive. And now in order for that to do so, we have to attach these two resistors, about 10 k ohms, which is fine. I've got two 5.5-ish Ks here, and they're in series, if you can see that. We've got, so we have our green wire, don't mind the prototyping, fabric cobbling, so that's right there, attached to this guy, which is attached to this guy, which is attached to ground. That's what they, well, a drop down resistor, kick down resistor, bleed off resistor. So that essentially limits your flow. So that's really all there is to it. Now let's change this up a little bit and let's put this on a nice little board. Oh, I got voltage leaking from somewhere. Something ain't right. I probably roasted, blew up this MOSFET. Anyways, so if you can see, stop shaking you around for a minute. There's our model, the T240 BV7 Gulf 1-4. So MOSFET works like a relay switch or a contactor. One we're using here is that the 240. So you got 3 pins. You got your gate, your drain, and your source. I'm going and looking at diagram. I'll provide a link for this. It's on electronicstutorials.com. So here we have our basic circuit. Let's flip this. No, it's better if I go like this. Okay, so we've got oh, that's probably what it was. So you need a little bit of resistance between your your high voltage and your positive side and your gate, but also you need resistance between your gate and your negative here. So that way, because otherwise if you were to energize this gate, your source voltage would go right through, and it would latch and it would keep running even if you remove that. So in order to unlatch it, you would have to ground it. To alleviate that, we put a resistor in parallel here. Sorry, excuse me. So once you get your lower resistance, which would be your triggering, and we can get that based off the data sheet, that'd be your RN, not your RGS, but your RN. I think that's what the problem is with mine. I didn't have the resistor in line. Regardless, I digress. So what we're going to do is mock this up, but you've got to have a, where do we have to have a diode? Ah, yeah, here we go, flywheel diode. It has to go from your drain towards your voltage source, so the voltage can only come the one way. You know what I mean? It'll be easier if I show you. We're just going to build it. Get that out of the way. Okay, so what we're going to do is we're going to take our MOSFET. If you have this proto board, you'll be able to follow along really easily. So what we're going to do is we're going to take our MOSFET, and it's going to go Not on this set of holes here, but the second set down. If you can read the writing. If you can read it. Yeah. Nito torpedo. We're going to put it on this second set of holes. And we're going to orient it this way. You see? Like so. We're going to turn it. Stick it in. Oh. Nope, that's not the one I want. I want it moved one over. There we go. Okay, so we've got our little doodad here. You can see the traces it's on. We're going to add our power wire right next to it, or our trigger wire right next to it. Then right next to that, I'm going to use 10K. Well, yeah, I will use 10K ohms. So what we're going to do, we'll take our little pliers. If you have pliers, you can use your fingers. If you don't got pliers, we're just going to take this. Just going to give it a little bend. Don't got to be forceful. It's very thin. She's going to go. About there. Yeah, it doesn't have to be perfect, but close is good. So then we're going to put it right next to it again. We're just going to go parallel into the next available hole to where it sits. Then, if you can tell on the traces, right here, we're going to go right next to it, and then we're going to go down from this one down to this one here. And this big one, this is on this left L that we have here, that's going to be one of our negatives. So we'll just do that again quick. The reason I'm using 10K as a value is because I saw it on a tutorial for a different type of MOSFET, and you know, it's probably going to be okay for us. So these are two 5K diodes. You could use a single 10K. If you're using a single 10K, then you wouldn't have to go all the way down to the bottom like I'm doing here. You could simply do a little bit of a diagonal over to this top row. Okay. And next we got to get our diode. And now our diode is attached to our middle leg, which is our drain of our MOSFET. Now I did just salvage a diode, and for the life of me I can't seem to find it. Of course, isn't that always the way it works? Okay, so the diode is going to be oriented in such a way so that the stripe on it is attached to our middle leg. So I gotta give it a little bit of coaxing. As you can see, there's a bit of shmoo on there from the salvage out of my old alarm panel that was removed once we moved in for the new one. Just gonna be very gentle. And these components aren't necessarily fragile, but I mean, it's no Detroit iron. The diode is also going to end on that same leg. So we are going to find our middle pin. You see the row? You see the row? Because I do. We're going to put it there. And we're just going to rotate this guy. And hopefully we'll catch one of these holes on the end. Probably. Oh, I got it backwards. There we go. And we're almost home free, to be honest. Now the biggest thing we have to do is hook up our large power wires. And then solder it all together. So, if you're new to the channel, I am a licensed electrician by day. I work in a steel shop, industrial environment, so I like to use wires that can handle the power. So we're going to take a number 14 solid. I've mentioned this in one of my previous videos, how I'm going to throw Welcome onto the bus again because I can, because I'm an electrician. In one of his live streams he said that he prefers to use stranded wire over solid wire because it, I think what he meant to say is it's easier for him to work with. Because what he had stated was that it has higher current carrying capacity. That is false. Silicone insulated wire has higher, well, not higher current carrying capacity, but higher heat ratings. Which means technically it could potentially carry more current. That doesn't mean that it does necessarily. Okay, so I'm gonna start. You know what? Screw it. We're just gonna dive into it. We're just gonna solder this all together. So don't be shy with the flux. It ain't gonna hurt you. Well, if you leave it on for like a week, it might. Oh, that's okay. Let's be a little bit shy with the flux. Whatever. But yes, for the cross-sectional area, solid wire. Oh, pro tip, if you ever need to clean your soldering iron right quick, fast, in a hurry, get your flux and just go. Yeah, for the cross-sectional area, solid wire actually has more current carrying capacity. And when you ply it, it stays the shape and orientation that you so choose. So I'm just melting some of this off because I couldn't do a little dab. Put a little on the iron because we have lots of flux here. There, that's one. A little on the iron. Maybe a touch more on the iron. Touch on the iron. Try to have a steady hand. I clearly had too much coffee today. Say no to drugs, kids. But yes, so for your high power wires, I highly, highly recommend using solid wire because you can find it everywhere. I know stranded wire might seem appealing because it's easy to bend, but that's part of the issues. You don't want, oh shite. Okay, there we go. Saved it. Saved it. You saw that. You don't want your stuff just flapping in the breeze. So when you're soldering things like wires, it's not that crucial. But when you're soldering on sensitive components like a MOSFET, you want to try to do it fairly quickly so you don't burn it out. Resistors are like wires. They don't really care that much. Well, it looks like we need a little bit of flux down here. I'm trying to wipe some of this off the brush because it's just lots. That's just way lots. Just give it a little smear. Try not to touch the hot things. A little bit of solder on the iron. Just kind of hold it there until it flows. Give it a second for the flux to disappear. And that's it. Now for the diode. Diodes are a little sensitive as well, but not as sensitive as transistors and other various chips. Okay, so now that we've got those all on, I can find my snips. We could snip them, but I can't seem to find my snips right now. Regardless, so now what I gotta do is I'm gonna tin this wire so it adheres more readily. So don't be shy with the solder on this. Top side, bottom side, all the sides. There we go. And also be helpful to put a little bit on the board itself where we plan on making this connection. So we're just a couple little dots there, and we're also going to do the same on this side. Good, they're not touching. So now this part gets a little hot, so I like to hold it with a plier. I'm just going to prop this up so we can get a slightly better look at it. So we're going to take this wire, we're going to go right here. So we're going to press on the wire with the solder. God, I need to give this a slight bend. Just a slight bend. Just because we have some interference right now. Handy hands would be handy right about now, but whatever. Mama didn't raise no quitter. Oopsie doodle. I'll lift it off. That is a fairly sound joint. And we're going to get another colored wire. I guess I should bring that into view. Okay, there's that. Now to do this again. Same deal. We're just going to give it a little bit of a bend. I'm going to go a bit on this side, just because we're getting a bit close. swear that's the chair I'm sitting in. It's not great. But even the professionals have their down days. Okay, better way to word this. White wire is your negative in. Your red wire is your negative out, back to your battery. How's that? Zoop, and zoop. So we're going to take our negative in, our negative out. Oh, nothing's running. That's a good sign. And now, so we're going to go on to the hot and so me touching this hot here is simulating the switch closing, opening, switch closed, switch open. And the benefits to a system like this is that you can keep all of your factory wiring in your blaster. All you need to do is change your big wires that go directly to your motors. And luckily, in the Rapid Strike, it's all right there. It's right there. So, stick like a little 9-volt or a little, a couple AA's or whatever, in your blaster. And depending on what locks you've removed, in your Rapid Strike, for example, you can take the black wire that is running to your factory motors, or to your motors, and you just hook that up to your negative. At which point, you take your positive, you hook it up to that guy, because your red is your power to the rest. So you take this little doodad and you solder those, heat shrink those together. When you're done with this, you can snip all of your leads and you can cover it in silicone if you like. You don't have to, but that's an option, so it becomes weatherproof. What I would recommend is, once you've got it, I'll get the shmoo out of the way. Once you've got it all how you like it, I'm probably going to redo this one resistor because he popped up. But if you leave your MOSFET a little high, then you can actually fold it down onto itself to slimmer the profile if you like. I mean, you could probably do a little bit better than that. If you really wanted, you could reverse the MOSFET and do everything on the other side technically, and then fold it back this way so this part would be on top of the diode. But this is just how I'm doing it, because if you look in here, with minimal cutting, these two short wires fit right in there. And if you're removing this one lock, this would fit in quite nicely. You just got to bend these a hard 90. So, yeah. So then this one would go, this guy would bend and go to wherever the negative pin is, and this one's just going to go to your motors, and it's all right there. So this is, remember, this is not a mod guide for a complete mod guide for the Rapid Strike. This is for how to build your own little MOSFET board. And if you want, when you're done, since there's all these extra pins that you aren't using, you can just go ahead and snip these. Be careful. If I was you, I would use a Dremel and a cutoff wheel and just go nice and slow. And you can trim that. You can trim this. Yeah. So there's that. Oh, and a side note: make sure when you're soldering your negative in, do not solder it to this bottom trace here, because if you do, then well, your stuff's just gonna always be on, and that's no freaking good at all. But yeah, I was hoping this one was gonna turn out a little bit better than my first one, which seems to have walked away. Oh no, here it is, it's hiding. But it's basically the same thing. But I think this MOSFET's toast. So yeah, there you have it. That's how you build a little MOSFET circuit. Real super easy. Remember, use a thick wire. Use a thick wire. Till next time, frig off and brap on.